Hi guys, welcome to another one of RT Dowlett lectures, and today I will be focusing on looking specifically at static electricity. Now, static electricity is a fundamental topic at the Csec level, and it's also revised at CAPE Unit 2. So it's a good foundation for and revision for both levels. So when we talk about static electricity, we are firstly talking about charges. So whenever I introduce electricity to students, I'm saying that we are firstly talking about a charge. So a charge can either be positive, right, or it could be negative. Now, where do we get charges from? We get charges from the atom. So if you recall from the Rutherford's model and then developed further by Bohr and Chadwick, that we have the atom being a nucleus, which is or containment of dense positive charges. And surrounding that nucleus, guys, we are going to have negative electrons. Now, what you guys will find is that because of the position of your electrons, it is easiest for them to move from the atom. Now, if you consider specifically a metal, due to the concept of metallic bonding, you are going to have a sea of mobile electrons. So when these electrons have gained energy, right, they are already free to move, which is why when we talk about in current electricity, a conductor, we deem metals better electrical conductors than non-metals. Now, when we talk about static electricity and we talk about charges, static deals with stationary or at rest. So static electricity deals with the transfer of charge from the surface of one body to the surface of another, right? So it deals with the transfer of charge. Now, typically for static electricity to be observed, you want your body to be insulated, because if your body is not insulated, then it can cause the charges to flow. If the charges are flowing, that is current electricity. Now, because we have started off the class by talking about static electricity dealing with positive and negative charges, we are considering three ways that these charges can move, right, from the surface of one to the other. And we are talking about charging by friction. Then you have charging by induction. And I'm going to put an asterisk by this one because contact is a little bit of cheating, because it's not necessarily that it's moving from the surface of one to the other, but in fact the charges tend to move through when we consider a conductor. But we still deem it transfer of charge. Now, when we talk about friction, we talk about two bodies which are rubbed against each other. So it is the transfer of charge when two bodies, and these bodies are electrically neutral. I'll explain that just now, right? When these bodies are electrically neutral and they are rubbed against each other. So there is some frictional motion. Now, when you talk about charging by friction, before we get into the actual process, you have to understand what electrically neutral means. So electrically neutral is where you have a balance of positive and negative charges. So if you have no overall charge, but you have a balance of positive and negative charges, then that is considered, the body is considered to be electrically neutral. Now, when you have a body being electrically neutral, right? So let's look at a very common example of transfer of friction. We have a polythene rod and we have a piece of cloth. Now, initially, we are going to let both of them have the same number of electrons. and protons, right? Positive, negative charges, right? Now, when polythene is rubbed against cloth, electrons tend to be transferred from one body to the next. So you're probably saying, well, why electrons, right? Now, every body, every substance has something called electron affinity. And it's a property of the body that facilitates. Affinity means likeness. So if I have a polythene rubbed against cloth, what I mean is those charges from my polythene electrons, because of their position in the atom, are most free to go from one body to the other. So if polythene is rubbed against cloth, then the electrons from either polythene will go to cloth. And how do we know which direction the electrons are traveling? That direction comes from the materials. Which one is more electron affinitive? Which one has a greater likelihood of attracting or pulling electrons? So if I compare polythene to cloth, polythene is more electron affinitive than cloth, which means that electrons now will be transferred from the cloth all the way to the polythene. So after the rubbing process has occurred, we can consider friction to be the generation of heat. So then the electrons, because their locality is on the outskirts of the nucleus, when they absorb that heat energy that is generated through the friction process of rubbing both surfaces together, then the electrons will absorb that energy and break free of the surface of the cloth and be transferred to the polythene. So after the process, you will find now that the polythene has more electrons. So the polythene becomes negative, while the lack of electrons on the cloth gives it a positive charge. And through friction, both bodies tend to have opposite charges. Now, the next one that we will start to look at is acetate and cloth. Acetate is like a glass, right? So the same thing, both bodies have the same positive and negative number of charges. When they are rubbed together, cloth is more electron affinitive than acetate. So what will happen is that electrons from the acetate will be transferred to the cloth. And after the process, I will find that my acetate rod will now have a positive charge, remaining a surplus of positive, and my cloth on gaining electrons will now be negative. So the same cloth was used in both cases, but depending on its electron affinitive value relative to the other material, it can either get electrons or get rid of electrons. Okay, so now let's talk about induction. Now, induction is not like friction because you want the body to come close to but not touching. So let us consider a metal sphere that's insulated. So I know I told you at the beginning of this lecture that we're talking about insulated materials. And yes, a metal sphere is a conductor, but if you place it on this insulating stand, it prevents the charges from flowing. So it will just kind of be present on the surface of the sphere. So here I have 3 positive and 3 negative charges. So in induction, you do not have the bodies touching each other, but you have a charged body being placed near to an electrically neutral body. Now this is different to friction, where you have movement, relative rubbing of surfaces, and then you have the 2 bodies being electrically neutral. But in induction, you have one charged body here, and then you have another electrically neutral body here. So you have electrically neutral, and then you have charged body here. And it is placed near to, but you don't have any touching taking place. What is going to happen is that you're going to have now charge segregation. So charge segregation is basically where you have the opposite charges being attracted to the side closest. So the negative charges will be pulled here and the positive charges will tend to be repelled. So one of the ways that we can basically get rid then, because induction is where you produce a charge on a surface that is opposite to the charged body. So if the charged body is positive, you would want a negative charge to be induced on the surface of the initially electrically neutral body. So what we do is that we earth this side. So electrons will now from the earth, because in electricity we consider the ground, the physical earth, to be a storehouse of negative charges. And if you look, and this is pulling from current electricity a little bit, if you look at all sockets, there is a third cable that goes to ground or earth. And the purpose of that is the earth cable, all of these connections in your house through your breaker box are connected to the earth rod. And this rod is buried deep in the earth, and what it does is that it is a safety precaution where all negative electrons flow safely down to the ground. So here you will find that if you had positive charges being accumulated on the side of the sphere, then you ground it or you earth it. And that is where you have a line, 3 smaller lines. That is what we call a earth connection. It just means that it is connected. So now you will have electrons flowing and neutralizing the positive charges here. So when you remove the charged body, you would find that this tends to have the sphere now would tend to be negatively charged. So charging by induction produces an opposite charge, induces an opposite charge on the surface compared to the charged body. Now the next one I want to visit is contact. And contact is basically where you have to have a metal surface because you are placing the two bodies in contact with each other. So one of them will be electrically neutral and the other one is charged. So let's say this one is positively charged. It has more positive than negative charges. So this is my charged body and this is my neutral body, right? So when that happens, I am going to have electrons being attracted all the way to my charged body, right? So when I separate them now, the initially neutral body would have lost electrons and it would have attained the same charge as the body it was placed in contact with. So because this body has a surplus of positive charges, it would tend to pull or attract the electrons, right? And then it would leave that body with a lack of electrons, which is a positive charge. Now, the next thing I want to talk about a little bit is the formula. So, an electric current is defined as the rate of flow of charge. And we can talk about charge as represented, could be either positive or negative, and it is represented by the symbol. So, a uniform electric field exists between two plates which are connected, one connected to the positive and one connected to the negative terminal, even of a battery. Now here you are going to have field lines going from the positive all the way to the negative. So you would have a potential difference V that builds up across the plates, and you would have a separation D. So we can consider something called the electric field strength E, which is V over D. So that is the volt per meter. And having a uniform field, you always have field lines go out of the positive all the way into the negative. Now, if you consider an isolated charge, that is a single positive or a single negative, you will have here that you have a positive charge and then you have a negative charge. Now your field lines will tend to always go out of the positive and they will always tend to go into the negative. And the direction of these field lines, because they are lines of force, they represent a region around a charge where you have an electrical force being experienced, is the direction in which a free positive charge would move if placed at a point in the field. Because like charges repel, if I had placed a test positive charge here, it would be pushed away because like charges repel. If I had put a positive charge here, it would have been attracted to the negative charge, right? So that is why unlike charges attract each other. Now here, if I had two opposite charges, the field lines will go from the positive all the way to the negative. They would go out of the positive and they would go into the negative. And typically where field lines follow each other, you would have a force of attraction. In the same way here, if you had a positive charge and a positive charge, there would be a point X at the center here where the field lines will not run, right? Will not be present. So in a case like that, you would tend to have no field lines, and when the field lines don't meet, you have a repulsive force. Now, the last thing I want to touch on when it comes to static electricity is the concept of lightning. Now, lightning is a discharge of electrons, right? And what you will find is that at the base of clouds, you will have, because clouds are droplets of water vapor, what you will find is that when there is a lot of moisture in the atmosphere, you have charging by friction between those water droplets, which are polarized, and the air molecules surrounding. So it results in, within the cloud, an accumulation of negative charges at the base and positive charges at the top of the cloud. So in fact, I could even go as far to say, as within a cloud, I tend to have a uniform electric field between the positive and the negative charges. When there is an accumulation of negative charges at the base of the cloud, they normally have discharge occurring. So if you have like a tree, you have buildings, it induces positive charges here. So the electrons tend to be attracted. If you have, that's why they tell you don't go out with an umbrella, right? Because the tip of the umbrella has a very large charge density, which means that it has a large concentration of positive charges. So now you would find that your electrons from the cloud tend to be attracted. So a precautionary measure is that very tall buildings have something called a pointed lightning rod. And what the pointed lightning rod is that it has a concentration of positive charges, which attracts the negative charges from the base of the cloud.